Hello. So I said in the introductory video that you could draw equations by wiring together some basic equations. So the question is, well, which ones, right? Which basic equations do we choose? And I want to be clear here that I could define anything. Like I could say that a wiggle with like a bunch of things corresponds to what I don't know, this is A, B, C, D. That could be, S squared plus 3b equals c. I could make up whatever I want. But it so happens that we can choose, there's a very nice set of basic things we can choose that allow us to write a lot of things that have very cute and nice reasoning rules. So this is what I'm going to use in practice. This is what part of equation Lego is a particular set of basic things that we tend to use all the time. And the most basic of all, I guess the most basic of all is this one. This is an equation with two variables because it has two sort of open ends of a wire, and this corresponds to A equals B. I guess I don't even count it because it's so invisible, but it's there. This is sort of equality. The first real basic equation is this one. We call it copying, and it says that A equals B equals C. It's just equality with more things. So we could do, we can have as many legs as we want, and this just says that all the variables have the same value. And this one has a companion, which is a funny little equation that it's an equation in one variable that essentially doesn't use the variable. One way of saying it is that it's the equation A equals whatever. If you like to think of diagrams as being, subsets of R to the n, here, it's n equals 1, and it's the set of all possible values. Just said any A is okay. We don't really care about A. This is sometimes called discard or ignore. Just say we ignore A. It doesn't really matter. It's a weird little thing, but it comes up a lot. It's quite useful when you think about reasoning and that kind of thing. So this is the core of the basics of any equation Lego kind of thing. We'll need those. And then we start to have some more semantically interesting ones. And the first one is addition. So this is A plus B equals C. And it has a companion, which is this white node with only one thing, which is A equals 0. And likewise, you could draw one with a bunch of legs in one direction and the other, and it's just that the sum of the inputs equals the sum of the outputs. And using this, we can start already doing a lot of linear algebra. But what we really need for linear algebra is this one. So here, for a number k, for example, k equals 3, this equation is ak equals b. For example, 3, this is like 3a equals b. And we also have, this one stands for -1. This is multiplication by -1. It happens a lot, so we just have a square for it. And now, with all of that, we can already do a lot of stuff. We can do linear algebra, so I'll have whole videos about graphical linear algebra using those. We can go a bit further. This is a equals 1. And this goes a little bit beyond linear algebra, but not much. And it gets fun when we get to other things. So one other thing is multiplication. That sort of goes well with 1. And this is AB equals C. And now we start talking about polynomials and roots and that kind of stuff. And on a sort of different level, so far this is mostly about sort of operations, but we could also have more equation-y things. For example, this one, which we write with a little triangle to the right, is comparison. So this is A bigger than B. We could have different. I have not used that one much. That could be A different than B. What else could we have? A fun one that goes a bit beyond what we've been doing so far would be differentiation. So this would be dA over dt equals b. So far, my variables were numbers, but for this one to make sense, I need variables to be functions of time, but that's fine. I can do that. You're noticing, you can notice that I can make up a lot of things. If you have an idea of an equation that you find sufficiently like sort of cute, like a simple thing that you want to include, you can just include it. Like the only constraint is the equation needs to have, a certain number of variables as input and output, and that's it. You can do whatever you want. I think I've covered all of the ones that I've seen in papers so far. So I'm going to stop here, but I might make further additions if we invent new cool things.